All right, so here we go, geometry. We are looking at section 3.2, angles formed by parallel lines and transversals. Let's do this. So first thing, my name's Mr. Butler. This is, I don't know what day or period it is, but let's just do some examples here. So according to the corresponding angles postulate, if two parallel lines are cut by a transversal, then the pairs of corresponding angles, so here's the big thing, corresponding angles are congruent. That's it. That's our kicker. That is the important stuff. So matching angles, remember we talked about kind of angles in the same location are going to be congruent. So we got this one here and this one here, both in that bottom left position. 2 and 4 in the bottom right position are congruent. Okay, so we just have to determine here for a second, are they congruent? Are they not? Let's do that. All right, so I'm going to scroll down just a little bit. It says determine whether each pair of angles is congruent according to the corresponding angles postulate. So 1 and 2. All right, now this is where it does help if you kind of cover them up and look at them separately. So I'm going to do that real quick. So if I cover up 2 here, and I'm not looking down there, I see that this 1 is in like the bottom left, right there. So it's in that bottom left corner. Now if I go back and I get rid of that, where's the 2? The 2 is in the bottom right. Those don't match. It should have been over here for it to be corresponding. So no, it's not corresponding. There we go. All right, let's look at angles 3 and 4. Again, it helps if we kind of cover them up with a finger or something just to not look at it and look at it one at a time. So I see the 4 here, and that's in, I guess, what you could call the top piece. So then I'm going to look at the other one and see where that is. It should be right up here. And it is. There it is. Look, it's in the top. Okay, so those are corresponding. So yes, it's corresponding. We could say that angle 3 is congruent to angle 4 because of the corresponding angles postulate. Now, some basics. This is almost too easy. It's just saying find the measure. Well, if we're talking about corresponding angles, and that one's 67, then so is this one. So there you go, 67 degrees. Piece of cake. Let's look at the next one. We have an X here and a 42 here, and they happen to be corresponding angles. They're both in that lower left position. So it's asking, what's HJK? Well, X is the same as 142 degrees, so it's just 142 degrees. It's almost kind of so simple, it doesn't really make that sense that you're really thinking about it. So let's look at something with a little more complexity to it. Not a lot, just a little. All right, so when I'm looking at these, notice that I have corresponding angles because they're both in this kind of left location. And they're both algebraic expressions. So what I can do is if I say that, well, that angle is congruent to that angle, then I know that 3x plus 23 is equal to 4x. All right, from here it's just algebra. I see I could regroup by putting some 3x negatives there. Then I got 23 equals x. And cool, so I'm done. Wait. No, I'm not done. Why? Because it just says x equals 23. And x equals 23 isn't what it asked us. It asked us to find the measure of angle ABC. So here's ABC, and that's 4x. I could really plug it into either one because they're the same value. I'll plug it into the 4x just to try and stay consistent. So that'd be 4 times 23 equals measure of angle ABC. Well, what would that be? Let's see. 4 times 20 is 80. 4 times 3 is 12. Put those together. You got 92 degrees. Almost a right angle. Close to one. A little bit over, but not quite. All right, let's look at this next one. It says we got 5x and 3x plus 50. Okay. Let's see where that takes us. Well, we see that these are corresponding angles again, and corresponding angles are equal. Therefore, these are equal. 5x equals 3x plus 50. Piece of cake. All right, so now I just solved this equation. I'm going to subtract 3x from each side. 2x is going to give me 50. Then I divide by 2, and x equals 25. right? Almost. Now we got to take that information, plug it back in. So we're going to take this x, put it into that 3x plus 50, because measure of angle MPQ is 3 times 25 plus 50. Okay, so that's 75 plus 50. So we got 125 degrees. There you go. Piece of cake. Piece of cake. All right, let's keep going here. You guys doing really well. We're going to finish up this review for mastery, and that'll wrap up the first of our 2 videos. So we scroll down, and boom, there we go. We got more going on here. Angle pairs, if they're alternate interior, like 6 and 7, those are going to be congruent. Or if they're alternate exterior, like 5 and 8, those are going to be congruent. Again, this is like piece of cake. You know, some things are congruent, some things aren't necessarily. But, ooh, this is new. If 2 parallel lines are cut by a transversal, then pairs of same side interior angles are supplementary. It's not necessarily in this table up here, but look at this. That means that these 2 over here are going to add up to 180, and these 2 on the other side are also going to add up to 180. Oh, so we got sometimes it's congruent and sometimes it's not. Okay, well, here's what I think of when I see this, and just so you guys kind of catch on. I think of like, okay, so let's say I'm going down a line, and then I turn, and then I turn again. That's like a U-turn, see this? U-turn, and that is 180 degrees. It's like you turn a little bit, and then you turn a little bit more, and you make a U-turn. And U-turns turn you in the opposite direction. That's 180 degrees. So that makes sense. Okay, let's keep that in mind when we kind of go through these. Let's do some calculations. All right, so we got, how many do we have down here? Just those 6? Cool, we'll put them all on the same screen. All right, so let's see what we're looking at. First of all, I see that these are alternate interior angles. And I'm going to start marking these in such a way that hopefully you guys will see kind of a pattern. So I want you to see this pattern. I'm going to use some color coding here. I almost see that like these 2 are vertical, and then, oh wait, these are alternate interior, and those are equal, and then these 2 are vertical. So I got all those red angles. And then I could also do the same for like the other ones. Like these 2 are vertical, so those are congruent. But wait, this blue one is congruent to this one over here, so those are alternate interior, and then those 2 are vertical down there. So we got either blues or reds, and if you put a blue with the red, it's going to add up to 180. But if you have a blue and a blue, or a red and a red, then they're congruent. Ooh, check that out. All right, so we got 3 and 111. So measure of angle 3 equals 111 degrees. It's that easy sometimes. All right, for number 8, it is pretty easy, but there's something going on with this symbol that's not exactly obvious. Please notice that it's a right angle, and right angles are 90 degrees. Because that's 90 degrees, then I look up at this 4, and I see that this is kind of a weird one because it's a U-turn. So that means I'm going to have 90 degrees plus the measure of angle 4 equals 180 degrees. And when you subtract that 90 degrees, it happens to also be 90 degrees. So measure of angle 4 equals 90 degrees. So if you have, this is interesting, if you have a 90-degree angle, it looks like they're both equal and supplementary. Go figure. All right, let's look at the next one. So I got this 38 degrees and this x down here. They're asking me to find RST. Okay, so find RST. What could we do? Well, let's take a look. It looks like I have a red one and another red one. That's cool. So I have 2 red ones. That means that they would be equal. And is there another way I could look at that? Yes, these are alternate because they're on opposite sides of the transversal, which is going right here through the middle. And they're exterior. And alternate exterior angles are congruent. All right, so RST x equals 38. No big deal. Keep on going. All right, let's look at the next one. It looks like we have on the inside here, we got alternate angles because they're on either side of the transversal. Here's our transversal through the middle. And they're on either side of that. So they're alternate and they're interior. and those are congruent. That's the relationship for alternate interior angles. So that means I could set these two expressions equal to each other. A plus 28 equals 2a. And then from here, it's just an algebra equation. So we're going to subtract 28 equals a, lots of a's, and then there's 28 equals a. So is that, no. Oh, we got more. So 28 equals a, but they're asking us to find m and p. So I got to plug this a back into that. All right, so then that gives me 28 plus 28, and that's going to be 56. Finally, a new number. All right, 56 degrees. Let's keep going here. So we got this next one. What do we have going on? It's either supplementary or congruent. It's either going to be add up to 180, or it's just going to be equal. Well, I think it's equal, but let me double check. It looks like this angle's right there, and this angle's right there. And those are on alternate sides of the transversal, because the transversal is right here. So they're on alternate sides, and they're inside the other two lines. So that would be alternate interior angles. And alternate interior angles are congruent, so we set them equal to each other. That gives me 5y equals 2y plus 78. Now it's just a little bit of algebra. So we move the 2y around, and then we get 3y equals 78, and then we divide by 3, and we get y equals, ooh, how many times did that go in that? That's a lot. So 25, and then one more, 26 times it looks like. So there we go, y equals 26. But that is not what it's asking. It's asking what's wxz, and here's wxz. So that means I got to plug it in there. So we got 5 times 26, which is going to equal 130 degrees. That's it. Okay, number 11, check. Let's go past it to number 12. What's happening here? All right, we got this angle and this angle. This is new. All right, now we're talking something different. Just erase there so I can see what that number was. It's a 3n minus 47, n plus 7. Notice that these are same side interior angles, meaning that they're both inside the two parallel lines, and they're both on the same side of the transversal. So there's a transversal that I kind of colored in, and they're on the same side. That means that they're going to be adding up to 180. So that means I'll have something plus something equals 180. All right, so then I'll have 3n minus 47 plus n plus 7 equals 180. Now it's just combining like terms, working our way through this. 3n and n is 4n. Negative 47 plus 7 is going to be minus 40 equals 180. Now we keep going. We add 40 to both sides. We got 4n equals 220. All right, this is going to be a big number. So, but 4 times something equals 220. That's huge. Looks like it's going to be 56. Is that what it is? Let's see. 4 goes into 22 5 times. Goes into 20. What's left over? 22 5 times, and then 20. Oh, 55. 55. Yeah, 55. So it's going to go in 55 times. So 4 times 55 is 220. That means that n equals 55. But not done, because they're asking me to find measure of angle ABC, which would be this one, 3n minus 47. But I'm going to cheat, because I know that if I were to plug it into n plus 7, so that means n plus 7 equals the other one. It's going to be 55 plus 7. That is, so 55 plus 7 is 62. Now I'm going to go backwards, because I know they add up to 180. So then I'm just going to say, oh, well, 180 minus 62 would give me 1, and then this would be a 1, and then an 8. 118 degrees, and there you go. That's it. All right, that's the end of this video. That was 15 minutes. That's kind of long. I'll do the practice as well. I'll try to keep that one really short, and then that'll be it. You guys will get on to the book work from there. Have a good one.